we're going to go through binomial expansion. And when going through binomial expansion, we're going to use something called Pascal's triangle. And you're familiar with Pascal's triangle? Okay. So just as a quick recap, essentially the way you set up the triangle, we start with the value of 1, and then we continue the value of 1 down the left and the right, setting up a large triangle and adding the values in between. So the first row is 1, the second row is 1 and 1. The third row is 1, and then we add the 2 in the middle, gives us 2, 1 on the outside. Then we have 1 in the middle again. We have 3, because 2 and 1. 2 and 1 is 3, and 1. That makes sense? Okay, by this point, we're at row 1, 2, 3, 4. Okay, so we're on the fourth row here, and we're going to continue down. Row 5 gives us 1, 4, 6, 4, 1. Next row gives us 1, 5, 10, 10, 5, 1, and we'll go one more. 1, 6, 15, 20, 15, 6, and 1. Does this make sense? Okay, so 4, 5, 6, 7. And this is a infinite pattern. You can continue going forever. The reason we set this up is to help us with binomial distribution. What we mean by binomial is there are two terms that we have to distribute. And in this case, it's to the power of 9, which means it's a rather large binomial distribution. If we were to set this up, recall using maybe something like FOIL, there would be 9 sets of this. It would get extremely long and tedious. So we use this triangle to kind of help us get through this idea here, okay? What we're going to do with it, and now technically the binomial doesn't start till row 2. And this would actually be to a power of 1. Have you seen that symbol on a calculator? Yeah. This here would give us the power of 2, okay? 3, 4, 5, that's a 5, 6. So in other words, in Pascal's triangle, our binomial distribution is actually always one exponent less than the row we're in. So if we're going to get to the power of 9, in Pascal's triangle, we have to go one row ahead of that. We have to get to row 10 in Pascal's triangle to really utilize the numbers. So we're going to have to continue this pattern. Okay, so how about you help me out with it here? We then go 1, 7, 21, 35, 21, 7. Oh, I missed something there. No, 35, there you go.
Yeah.
21, 7, 1. Okay, that's what, row 8? Here's 9. What's that going to be? 56, 70, 56, 28, 81. Let's just count these out. 8, 9. What row did we say you had to get to?
10.
Yeah, we have to get to 10. Okay, so we get to this row. 9, 36, 70, 84, 126, 126, 84, 36, 91. So, what it goes to show is there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms, right? And when we get to the 10th row, there will be 10 terms involved in our final answer. And we're going to use all these. So, along with that, we have to keep in mind, excuse me, that our exponents are going to be dropping from left to right. So in this case, let's call this, when they usually set this up, they usually call this A plus B, right, and squared. And what happens is when you get to this row, and I guess I'll draw it down here when we talk about A plus B, okay, the first term in this case here is going to have the power of 10 in this case, okay? So our A will actually be an A10 in this case. Our second term will be to the power of 0 when we're talking about the first term in the binomial distribution. From there, we kind of switch exponents. All of our exponents will always add to 10, okay? So when we get to this term here, our A will be to the power of 9, our B will be to the power of 1, so 9 and 1 is 10. We're always talking about 10. And as we move in this direction, our B exponents will increase while our A exponents will decrease. Okay, does that make sense?
Shouldn't the first ones be to the power of 9?
Oh, sorry, yeah, you're right. Sorry, it's an exponent of 9. I was thinking row 10. Yes, you're right. So, sorry, disregard that. Everything will add to 9 in this case here. Okay, and these are like coefficients that we'll be multiplying through our terms, okay? So we'll take our terms again. I'm going to rewrite the question here. 3y plus 5. So we have 3y plus 5, and it's all to the power of 9. You're right, it goes to 9. So our very first term here is going to be connected to our A, right? So our A term here is going to give us, this will be our coefficient in front. So I keep that coefficient. So this is all equal to coefficient of 1. So we'll keep the Pascal triangles in red. And then we'll take A's, we'll do in green here. So we have 3y to the power of, sorry, not 10, but 9 in this case. And we'll do our B terms in blue. This will be to the power of what?
0.
0, which means it's, it's just going to be a value of 1. So it really doesn't exist. So that's the first term. Then we add the next term along this. A coefficient will then be 9, so we'll have to multiply all of this by 9. Our A value will be 3y to the power of 8. And our B value here will be 5 to the power of 1. Yeah. So it constantly continues this pattern. So this is going to take a little bit. The next coefficient is 36. This will be 3y to the power of, you tell me.
7.
Yep. And 5 will be to the power of what?
2.
Good. Okay. Tell me what the next addition part will be.
84.
Yep. So we'll have to multiply by 84. That'll be our coefficient.
Times 3y to the power of 6.
Yep.
And 5 to the power of 3.
That's right. Okay. Let's try to get to at least half. We'll fit one more in here. What are we multiplying by?
126.
Yeah. 126 times
3y to the power of
5, and then
5 to the power of 4.
can I just fit it in there? Okay. Okay. So what's good about this is this pattern, because we've gotten to the middle of Pascal's triangle, is going to just repeat going the other way in terms of coefficients. Just our A and B value exponents are going to be switching. So we will get different values, but let's try to equate what we have because this is a huge number we have here. So let's try to simplify what we have so far. So in the first one, our coefficient 1 is not going to change anything. We're essentially going to have what?
3y to the power of 9.
Okay. There's one little thing though. When we have this, it's actually 3y times 3y times 3y. So it's actually 3 to the power of 9 times y to the power of 9. Okay?
Right.
Okay. So in that case, we'll bring up a calculator. I'm going to get you to help me go through this. 3 to the power of 9 is a very large number, 19,683. So let's actually put that in. Do you remember what I said there?
No.
I don't either. 683 y 9. This becomes a value of 1, which is irrelevant for us. Okay. The next one. Well, we have 5 times 9. That's going to be 45. Right? Times 3 to the power of 8, and then it's just going to be 8. Yeah, y will be the power of 8. So we just got to figure out what our coefficient is in this case. So we have 45, and we'll do 3 to the power of 8 equals times 45, 29, 295,245. 295,245. Okay, great. So we have to continue this process out here. I'm just going to take a look. 8 minutes. Okay, so we did a bunch of the calculations. We got to the 5th term. We still have to do 1, 2, 3, 4, 5 more. So quickly try to jump through this. So this is the first half of our answer. Second half of our answer, our coefficient, we recall, is going to be 126. But in this case, A is going to be the power of 4. So we're going to have 3y to the power of 4. And our B is going to be to the power of what?
5.
That's right, because we always know the exponents have to add up to 9, right? Our next coefficient, we can kind of just work backwards. I can jump up to Pascal's triangle and look, but because it's symmetrical, I can kind of just look at what I had done beforehand. Yeah. 84, 3y to 3, 5, 6. Excellent. 36, 3y to 2, 5 to what?
7.
Yep. 9 by 3y to 1. Oops. And then 5 to 8. And then what will the last one read?
3y to 0 and 5 to 9.
Yeah. So 3y to 0 is not important. The
Yeah.
1's not important. It's really just going to be 5 to 9. All right, and we'll calculate this one quickly since we already know, and we'll get a final answer here. We want to do so because it's such a large answer. Here's the first half of what we got. It's up to the 5th term, our 6th term, 7th term, 8th term, 9th term, and our 10th term. So like we said, there'd be 10 terms in it. Okay, so pause it if you have to double check your answer. But that's how you use Pascal's triangle with a relatively difficult one that took a very long time to do.